So as to the typical sintering schedule, the most common one that people often use are so-called isothermal sintering, which is essentially you go to a fixed temperature and then hold at that temperature for a certain time. That is what people mean by isotherm, the same temperature. And this is what the so-called temperature time schedule or thermal profile. The vertical axis would be temperature, horizontal would be time, and of course you start from low temperature, room temperature, for example, and typically ramp up with certain heating rate, like 5 degrees C per minute, 10 degrees C per minute, and reach to your target temperature, and then hold at this temperature for a certain time. That's what people call isothermal, at its constant temperature. And after that isothermal temperature range, depending on your requirement, you may just let it cool in a controlled fashion, or just turn off the heat and let the system gradually lose heat by radiation, thermal conduction, and cool slowly. Okay, so this is so-called isotherm, and the heating and the cooling rate for these types of heating is typically limited by the furnace. What types of heating system are we using, and the sample size? You can imagine if your sample size is large, it's difficult to ramp up quickly, to maintain the same temperature and ramp up quickly temperature. Make sense? If you have a lot of sample in there. On the other hand, if your sample is very, very small and your furnace can heat up very quickly, of course you can do that, but it depends. This is most common isothermal sintering. Not the real isothermal. Why do I say this? Because it always you have a so-called finite heating rate. This heating is never ever zero, like a zero time. It always takes a finite time from low temperature to high temperature. Your heating rate typically 5-10 degrees C. Sometimes you can go to 100 degrees C, but even 100 degrees C or 200 degrees C, you're still talking about from room temperature to 1000 something above a few minutes, right? So it's not zero time. So that's why we say it's not exactly isotherm. Of course, people can do different tricks to further increase the heating rate, but it's still a finite heating rate. Significant sintering always occur during heating up, and actually may also, if you haven't finished it, also during the initial stage of the cooling. Make sense? Kind of, you can imagine the sintering happen here, but also when you're getting close to that, you're also here sintering some. Okay. The other type of so-called temperature time schedule is called constant heat rate sintering. Something like this. Just constant ramp to a target temperature, no hold, directly cool. Constant heating rate sintering. Okay. And people use this for some special like shrinkage types of study, like for diatometry. Quite often you constantly heat up to that temperature and then you don't hold. It's done. Okay. Of course, in that case, you quite often have to heat up to a temperature that is somewhat higher than your isothermal temperature to complete the sintering. Make sense? Okay.